In this lecture video, we're going to learn about percentiles, specifically quartiles, and then building our 5-number summary to create a box plot. Let's take a look at this data set. We have test scores for 40 students. Notice that these test scores are already listed for us from least to greatest, which is important when we're talking about percentiles. So what exactly is a percentile? Consider the data value 63. We can actually say that 63 is the 32nd percentile. That's because 32% of all of the data values are less than or equal to 63, and 68% of all of the data values are greater than or equal to a score of 63. So whichever student scored a 63 on their test, they may have gotten a 63% on their exam, but compared to the rest of their classmates, they scored in the 32nd percentile. 32% of the class scored less than or equal to their score on the exam. Formally, the pth percentile is a number such that p% of the data is less than or equal to that number. Let's suppose we're looking for a specific percentile. Say you need to find the 30th percentile or the 50th percentile. We can use what's called the percentile locator, and we denote that with a capital L. And we calculate L by dividing P by 100 and then multiplying by the total number of data values, which is our capital N. If we do this calculation and we find that L is a whole number, then the pth percentile is between the values at location L and L plus 1. If L is not a whole number, then the pth percentile is located in the position of the next greater whole number. So we round up to the next whole number. Let's try a couple of examples. Suppose we want to find the 60th percentile. In this case, our p is equal to 60, and we can calculate our locator value L by dividing p by 100 and multiplying by n, the number of data values. In this case, with p equal to 60, we have 60 divided by 100 times 40, because there's 40 test scores. Putting this into our calculators, we find that L is equal to 24. And since our L is a whole number, 24, we know that the pth percentile will be between the 24th and 25th data values. Looking at our set of data, listed from least to greatest, the 24th data value is 76, and the 25th data value is 77. So the 60th percentile is right between 76 and 77, or 76.5. Let's try another example. Suppose at this time we want to find the 72nd percentile. In other words, we want to find the test score such that 72% of the entire class scored less than or equal to that score. We will calculate L by finding P over 100 times N. And in this case, with looking for the 72nd percentile, P is equal to 72. So we'll do 72 divided by 100 times our N, which is 40. Putting this into our calculators, we find that L is equal to 28.8. Since our locator value is not a whole number this time, the pth percentile is found in the position of the next greater whole number, or the 29th data value. The 29th value is 80, so the 72nd percentile is 80. 72% of all students scored less than or equal to an 80 on this exam. Let's talk about some special percentiles. A set of data can be broken up into quartiles, or 4 quarters of the data. But in order to do so, we simply need to find the first, second, and third quartile. The first quartile, we often write as Q1, is equal to the 25th percentile. It separates the first 25% of the data from the other 75% of the data. The second quartile, denoted Q2, is equal to the 50th percentile. This separates the first 50% of the data from the second 50% of the data. This is also precisely the same thing as the median. The third quartile, often denoted as Q3, is equal to the 75th percentile. And this value separates the lower 75% of all of the data from the upper 25% of the data. Let's find these 3 quartiles for our data set. We'll start with the 25th percentile, or the first quartile. In this case, L is equal to 25 over 100 times 40, which is equal to 10. Since we have a whole number, the first quartile is between the 10th and 11th data values, or between 57 and 59. The middle of 57 and 59 is simply 58. So the first quartile is 58. To calculate the 50th percentile, or second quartile, we again calculate our locator value of L. This time we'll do 50 divided by 100 times 40, which gives us an L of 20. We again have a whole number for our L. So this means that the 50th percentile is between the 20th and 21st data values. In this case, those are both 72, and the middle of 72 is simply 72. So the second quartile is equal to the score of 72. Finally, let's calculate the third quartile. In this case, our L is equal to 75 over 100 times 40, which is equal to 30. So the third quartile is between the 30th and 31st data values, which is between 81 and 81. And of course, the middle between 81 and 81 is simply 81. So the third quartile, or 75th percentile, is 81. The interquartile range is how far the middle 50% of the data is spread out. And we can calculate that by simply taking the third quartile, Q3, and subtracting from it the first quartile, Q1. For our example, the interquartile range is equal to Q3 minus Q1, or 81 minus 58, which is simply 23. So that means that the middle 50% of the test scores are spread out by an amount of 23 points. Now that we know how to find our quartiles, we can summarize a data set using the 5-number summary. The 5-number summary includes the following values. The first is the minimum value, or the smallest data value in the set. In our example, the minimum is simply the score of 30, the lowest test score. Second is the first quartile, or Q1, which in our example we found to be equal to 58. Third is the median, which is equivalent to the second quartile, and we found this to be equal to the score of 72. Fourth, we have the third quartile, or Q3, and in our example we found that this was equal to 81. And the last number in our 5-number summary is the maximum value, which is the largest data value in the set. For our example, this is simply the score of 98, the highest test score. Now let's turn this 5-number summary into a box plot. A box plot is simply a rectangle that sits above a number line and shows off the 5-number summary for a data set. It's another type of visual representation for a set of data. We'll start with a number line. Since our data set is that of test scores, I decided to go with a number line from 0 to 100. But we could have chosen a smaller number line as long as it included the values between 30 and 98. We need to mark the locations for the values of the 5-number summary. We start with the minimum value, which we found to be 30. So we'll make a mark directly above the 30 on our number line. Next, we have Q1, which we found to be 58. So we'll make a mark directly above the 58. Third, we have our second quartile, or median, which we found to be 72. So we'll place a mark directly above the 72 on the number line. Fourth, we have our third quartile, or Q3, which we found to be equal to 81. So we'll place a mark directly above the 81. And last, we have our maximum value of 98. So we place our final marker directly above the 98. The next step in creating a box plot is to draw a box. We will create a rectangle that spans from Q1 to Q3. And inside the rectangle, we draw a line for the location of the median. The last step is to draw a center line from the box to the minimum and to the maximum. And that is a box plot. Notice the features of the data that a box plot shows off. We can clearly see the range of values from 30 to 98. We can tell quickly that the lowest score was a 30 and the highest was a 98. We can also see that the center of 50% of students were clustered together between scores of 58 and 81, and the center of the data set, measured by the median, is at 72. You can also tell from the box plot that students that scored in the first and second quartiles have scores that are a lot more spread out than students that scored in the third and fourth quartiles. A box plot is a very useful way to display data. And that will conclude this lecture video on percentiles, quartiles, and creating a box plot.